right. Wonderful. Let's get started. So, welcome to today's Harvard Data Science Initiative Industry Seminar. I'm Jen Chow. I'm Director of External Engagement, and I'm pleased to introduce today's speaker, Scott Henry from Duo Security. Scott is a data science technical lead focusing on analyzing product data of cybersecurity applications to help keep companies safer. He's got deep experience at the intersection of innovation, economic policy, and equity, including work at the World Bank, Bain and Company, and the University of Michigan. Scott holds a Master's of Science in Information from the University of Michigan, a graduate certificate in Science, Technology, and Public Policy from the Gerald R. Ford School of Public Policy, and a Bachelor of Commerce in, Bachelor of Commons in Computer Science from the UBC. Scott, you're going to have to correct me on the degree. I apologize for that.
No
But
worries.
before I hand over to Scott, I'd like to remind our audience that there'll be time after his presentation for questions. So audience members, please use the Q&A function to send in your questions at any point during his talk. Please don't be shy. All questions are good questions. All right. Thank you and welcome, Scott.
Thank you very much, Jen. I'm excited to be here this afternoon, everyone, and excited to talk through beyond algorithms, why socio-technical systems matter in cybersecurity. When I was thinking of the title for this talk, it seemed like the trend in the last couple of years was to put beyond in your title. So I hope that really helps frame this presentation for everyone. When I was thinking through what to talk about today, based on my experience with data science and working in cybersecurity, I thought about a lot of the fun, complicated technical problems that we have to solve. But I wanted to take a step back and think through some of the day-to-day problems that I certainly find my team and others face quite a lot within cybersecurity. And that's not usually say the technical problems, but it's thinking through the people and process and often the data governance implications. And so overall, all of that starts to wrap up into socio-technical systems, which is what I want to talk a little bit more about today. Let's go ahead and get started. I am just looking at a black box. I can't see all of your wonderful faces attending this webinar. So I thought let's make this a two-way streak and let's use Slido. So I'll ask the hosts if you could share the Slido information, the link and the passcode in the webinar chat, or you can also scan this QR code or go to slido.com and enter that room to join the Slido. Throughout the presentation today, I'll ask a few questions, we'll do a few word clouds, and my goal is to understand a little bit more about folks that are here attending, see some of your thoughts as we maybe navigate some of the ethical dilemmas within cybersecurity, and try to make this as much as possible a two-way streak while I'm presenting before we get to the Q&A section. Now, let's double check everyone has Slido access, and we'll see if this is working here. When you hear cybersecurity, what words come to mind? I see two participants typing. That's making great progress. Terror hackers, yeah. I see people joining the Slido now. People are getting in. Complicated, breaches, risks, scammers, complexity, MFA, yeah. We can see lots of folks, hackers definitely come to mind, information security, business email compromise, fear, cryptography, privacy. Great career. I couldn't agree more. I've really enjoyed it. Computers, we see data breaches, antivirus, privacy, hacking, more MFA there. Phishing, certainly a big one, and that's something that Duo obviously always seeks to solve here. We'll give folks one more minute to get your last minute thoughts into the word cloud. Thank you for everyone for participating. I can't see your faces, but I'm glad you're here following along with me. Bad actors, complexity, complicated breach, expertise, yeah, inefficient. All right. Thank you, everyone, for contributing to this word cloud. I wanted to take a step back here and really think about some of the words that have come to mind as folks are thinking through what cybersecurity means. And the overarching theme of this presentation is starting to contrast the technical versus the human/process-oriented aspects. And when we take a look here at some of the words that come to mind, while I see some things around cryptography, malware, information security, some of those technical aspects are coming through, I certainly see more of the human process-oriented aspects. And to me, that points to almost immediately coming to mind that cybersecurity lives within the socio-technical system, and that it's not purely how strong are our algorithms, how good are our detections, but we live within this entire ecosystem of people and process. And that is what I'm going to be talking about today. So cybersecurity is a socio-technical challenge, not only generally in the industry of cybersecurity, but also when doing cybersecurity data science. My seminar objective is to think about exploring the interplay between people, process, and technology from a data scientist's perspective. I think often, and speaking from my own experiences in education, so much is focused on that technology piece. But we know that technology does not live within a vacuum. It's people who create it and processes that use it. And so how do we think about all of this coming together, and how can we as data scientists think through all of these factors when designing different systems? Human and process elements often have a more significant impact on cybersecurity outcomes than just algorithms alone. Cybersecurity is all about preventing attacks, but it's also about how people are using these security tools to do so. And so the systems we build need to factor this in. An example which we saw coming up in the word cloud was phishing. So, phishing defenses often fail due to human behavior, not technical flaws. When we think of push phishing or Duo specifically, often someone will just get a notification and say, approve that Duo push, and not necessarily checking if they were the one that received that. Or even phishing within emails as well. You can have the best security, best algorithms, but when it comes down to human behavior, sometimes that's where the people and process start to get involved. Some of the things that stand out to me as I was preparing this talk was there's a great textbook that was published a year or two ago called Data Science in Context, Foundations, Challenges, and Opportunities. And the authors of this textbook did an interview about it. And one of the authors shared that the first big revelation of data science was that data can be a key asset that offers real value. But the second revelation was that data can be a liability if you're not a good shepherd of it. And I think that quote underpins a lot of what we'll be talking about today. It's the individual choices that are made to design these various systems that often have an outsized impact. So much of technology today is focused on capturing and storing and locating data, but all of those efficiencies make data even more easy to cherry pick and use it out of context, often to advance erroneous points of view. And so what some of these authors in this interview are sharing is that as we make these great advances in data science, we have to view our systems living in the context. I'll probably say context, socio-technical, and systems a million times in this presentation, and really drill that one on home. So I'll apologize in advance for that. A brief overview of what we're going to talk about today. We kicked us off with an introduction. I'm going to share a little bit more about myself and Duo Security to give you the context of what we're going to be talking about today. Then we'll talk a little bit more about understanding socio-technical systems and cybersecurity. I'm going to share a helpful data science framework, ethos, created by the Academic Data Science Alliance, which is a really helpful way that I like to think through of the different stages of the data science lifecycle development. How can we think through some of these socio-technical issues and concerns we might have? Then I'm going to talk specifically about a data synonymization technique that we do at Duo and apply the framework to this case study. Finally, I will close by talking about the role of data scientists in the socio-technical landscape, sharing some observations I have with regards to cybersecurity, but just in general, how data science as a field and data scientists in industry can utilize some of what we've discussed today and not only build for technology, but build for people and process as well. So thank you everyone for coming along with me. A little bit more about me. Jen shared a wonderful introduction. I've been at Duo since 2021, and I'm the manager of our data science team. And we really focus on analyzing product telemetry from Duo Security, but also a few other cybersecurity applications, focusing on enhancing the companies that Duo provides, their safety and security. Previously, I was the data scientist at Bain & Company, and I also was the data scientist at the World Bank, where I focused a lot on science and innovation policy in emerging markets. From my perspective, I've taken a pretty interdisciplinary approach to my career. I have a Bachelor of Commerce in Computer Science, a Master of Science in Information, and then also from the Public Policy School at Michigan, a certificate in Science, Technology, and Public Policy. All this to say, this interdisciplinary approach, garnered from my experiences at the World Bank, combined with working at Bain & Company, have all sort of created this thought process for me around people, process, and technology. And that's sort of what drew me to Duo Security and has culminated now in a lot of the day-to-day work that I do and that my team does as well. Now you've learned a little bit about me. I'm curious to hear what your background is. So, pull up Slido again. Where are you coming from today? Is it from a computer engineering background? Are you data scientists? Are you in STS studies, science and technology studies? I'd be really curious to learn a bit more about folks. CI, CS, data science, innovation, biostatistics, data scientists, marketing. This is awesome. Thank you everyone for contributing. MBA, industrial psychology, manufacturing, federal information security and data privacy. Very relevant to this talk today. Information management, information technology, STS and public policy. Well, overwhelmingly data science. I think that might check out given who's hosting me today. Well, thank you everyone for contributing to the word cloud. It's nice to meet all of you. And it's great to understand a little bit more about where you're coming from. And hopefully I can tailor some of the forthcoming presentation to some of these fields as well. Now you've learned a little bit about me. I've learned a little bit about you. I want to talk a little bit about Duo Security. Duo was founded in 2010 with the mission to make security easy and effective for organizations of all sizes. And a few years ago now, we were acquired by Cisco. You might know Duo as the multi-factor authentication that you use to log into your email or university services or at your job. And sort of Duo entered the market with user-friendly multi-factor authentication, often abbreviated to MFA, which was sort of the key solution. And Duo takes this approach of a zero trust security framework, which is a departure from maybe how we thought about security a couple of years ago. But we operate under the principle that access shouldn't just be granted based on where someone's located in the network, but it's granted under the principle that access is granted under the principle that you've verified the user identity and the device security posture. And some of the core values here at Duo, which I think you might notice a trend throughout this presentation, is focusing on finding that unique balance between security and usability, and usability and simplicity. We want to make sure that Duo is easy to use and deploy, because when we think about some of the trade-offs when designing cybersecurity systems, but also data science systems, the most secure system you make, you can just not let anyone in, and then you have 100% security. The most usable system, you let everyone have access. Obviously, the extreme on either ends, doesn't really make an effective product. So cybersecurity often has to find and straddle that middle ground of being usable enough for end users to use it, to not really dislike the tool, to protect their security, while secure enough. And often it's negotiating that compromise. To get a little bit more of an understanding, I'm curious, have you folks used Duo before? I know I have. I used it even before I worked at Duo. I am curious to see. Yes, I love it. Okay, I did put that as the correct answer, but I am partially biased. Um, yes, but it's annoying, slowly rising up. Okay, I understand. That is certainly that balance I talked about before of how do we think about security and usability. So good to know we have some folks familiar. And for folks that haven't used it before or are just learning about it now, I hope throughout the presentation you'll learn a little bit more about Duo in the context of what we're going to talk about today. So let's jump in. Now you have an understanding of the direction we're going with the seminar today, a little bit more about me and what I do for work. Now I want to jump into the bulk of the presentation and talk a little bit more about sociotechnical systems. So for those that have not necessarily heard the term before, sociotechnical systems refer to the complex interplay between social and technical elements within an organization. Generally, this approach emphasizes the mutual influence and interdependence of human factors, such as behavior, culture, and organizational structure, and technological components, such as tools, machines, and software. So this starts to come back to that triangle, the people, process, and technology, and that system that lives within it. It generally advocates for, designing and managing systems by considering both of these aspects. And that's going to be what I'm going to focus on advocating for today. Why do perfect security solutions fail, right? And I think going back to our phishing example or to others, it's because users often bypass them or misuse them due to their social context. And that's finding that balance of convenience over security. We see this, for example, in mandatory password updates every 3 months, where you're taking your base password and then adding 1, 2, 3, 4 exclamation. And then another 3 months, it's 1, 2, 3, 4, 5 exclamation. And this is where some of those security solutions start to break down. Sociotechnical systems are sort of a foundational part of science and technology studies, a field that kind of sits at the intersection of, some policy, law, and social sciences and history. And the concept of sociotechnical systems was introduced a long time ago in sort of a foundational study of the field by Tristan Banforth, which was focused on understanding different methods and changes of coal mining. Bear with me here to understand how we're going to go from coal mining in the 50s to implications on data science. But the takeaway here was this study focused on analyzing a change in the way and the methodology of coal mining, which was introduced as seen as a technological advancement over the traditional methods. But the research has observed that this new introduction of this new technology started to disrupt the existing social structures and work practices of the coal mining teams. And then it overall led to significant changes to the role and relationships among the miners, affecting teamwork, communication, and productivity. And so this was this introduction in developing this socio-technical systems theory, which basically talked a bit about understanding the change in the technology or the methodology of coal mining and how it lived within that system of those social and organizational relationships. And so the kind of end conclusion was the authors were advocating that successful systems also have to integrate and consider human needs and social dynamics along with technological efficiency. This new method was better than technically better than the traditional method, but it disrupted a lot of the existing social patterns. And so we sort of take that foundational article from coal mining, which, for maybe any STS scholars I might have butchered, and now we bring it all the way into talking about socio-technical systems today. But we can see here that this concept, which broadly is think about things that exist outside of the silo, can be applied in many different instances. Ultimately, socio-technical systems rely on that foundational concept of outside of the silo, but then are combined with the consideration that most technical things and advances have political qualities, which is now pulling from one other work, which I have sources below here, is from Do Artifacts Have Politics? And this is a work from an article from the 80s that starts to illustrate how the design of technology can have political implications. And so we start to see here now, emerging in the field, the understanding of not only socio-technical systems, but as well that these technological advances and components that we just talked about can have inherent bias and political qualities. Because as we know, people build technology, and we all have and bring with us our personality and biases to the tools that we build. So how do we think about starting to mitigate that? With that in mind, thinking about why data science and cybersecurity is a little different, I think the considerations of socio-technical systems are important across all fields of data science. But I certainly found myself thrust into considering these a lot more because of operating in a cybersecurity environment. As we discussed, security constraints often force different trade-offs than other data science fields. And cybersecurity has a strong emphasis, especially the companies that provide it, on privacy, compliance with GDPR, compliance with privacy data sheets, and as well as adversarial thinking. And so now we exist in this environment where we're designing systems and tools and doing data science while also considering all of these other industry level considerations with privacy compliance and that adversarial thinking. And then on top of this all, we think of data science and cybersecurity to really consider those insider threats. And this thinks about that other angle of developing systems that can detect and mitigate risks from within an organization. And so you sort of have to have this heightened level of security, thoughts around data governance and privacy, because when you're the one helping keep other folks safe, they are relying on you for a lot of those considerations for their privacy and compliance. So as a cybersecurity company, you sort of take that a bit more seriously as well. And so as I started my career in cybersecurity, doing data science, building systems and tools, all of these were very top of mind. And it felt like a forcing function to think about the system that the tools and analyses that I build are going to live in. And that key takeaway is what generally brought me to the conclusion of thinking through that people, process, and technology. And so because of this heightened level, let's say, of scrutiny and compliance, it leads me to think a bit more about the difference in doing data science within a cybersecurity context. But I put this question to you: should it be that different, or should So a question to you folks as we dive into the next section, what is more important in cybersecurity data science? A highly accurate black box model that maybe exactly does what we're looking for with threat detection, or a slightly less accurate model, but that's fully explainable. Sometimes, I see some overwhelming consensus here, and maybe I should have not shown the results until folks had voted. Certainly in what I'm talking about today, it leans into explainability. But I think the conversation of trade-offs is very important. And while I wouldn't necessarily advocate for a complete black box model, later in the presentation, we'll talk about, the explainability of different models and how, given certain situations, it is a give and take. And certainly as we move to more AI applications, we move a bit more to that black box approach, but see huge gains in efficiency. And I think that has great implications for how we design systems. Okay, I see maybe after some persuading thoughts, we are moving to close to a third here for that black box model. Thanks for sharing your thoughts, everyone. Now that I've talked a little bit about sociotechnical systems and how I view data science and cybersecurity as slightly as a sort of this unique field, I wanted to talk through a framework that I found really useful for evaluating and thinking through these considerations that we're trying to talk about while doing data science. And this is the Data Science Ethos Framework. And this framework was created by an interdisciplinary team of social scientists, humanists, and data scientists working with the Academic Data Science Alliance. And the overall goal was to merge data science research, the data science research workflow with some sort of ethical framework. We often see organizations and different initiatives have codes of ethics. And while I find that useful, implementing a 20-page code of ethics doc in practice starts to become challenging. And that's why I appreciate frameworks like the one we're going to talk about today, or there's a similar framework put out by the Responsible Data Science Alliance as well. And both are pretty tactical frameworks that can equip data scientists to think through these necessary considerations at each stage of the data science lifecycle. The overarching points of this framework is that it emphasizes an importance on collaboration across disciplines. It advocates for ethical consideration and responsible practices. And then it helps to really guide data science processes through all of these different stages. And I think the staged approach can be particularly helpful here, as I think we often jump to data gathering and data modeling. But there's so much more here around, let's say, the work before the work that we do when it comes to interpreting a problem, when it comes to thinking through the problem definition. And this framework, I think, helps us go slow to move fast in the end. And so let's get into it. A part of this framework are these 4 conceptual lenses for social and ethical contexts. And the idea here is these lenses are useful to evaluate each stage of the data science lifecycle framework, which we'll talk about in the next slide, and really think through how we can evaluate some of the considerations that we want, especially that sociotechnical system, for the data science modeling and systems that we're building. And so the first is power, which focuses on the influence of data science on societal structures and power dynamics. So how can the decisions that you're making impact the outcome? Where is the power situated for the specific project that you're working on? Narratives explores the stories and contexts that shape data science practices and interpretations. And so it emphasizes the importance of understanding and communicating these diverse stories and perspectives in data science. And I'll note that the reason why I like this framework is that we have these 4 lenses, we have the different life cycle steps, and that for each stage, grouped under each of these lenses is a list of useful questions to consider and ask yourself as you're working through your project to really think through the ethical, social, and responsible considerations here. Next, we have positionality, which addresses the influence of the researchers and practitioners' background, experiences, and biases, and what you're bringing to this work. And then finally, sociotechnical systems, which advocates for integrating those aspects, the interconnectedness of social and technical aspects into this data science and take a holistic approach. So certainly the last point is what the majority of this presentation is talking about. But the other lenses here I think are really critical. And when I think about what differentiates very strong industry data scientists, it's thinking through these important factors in the systems you're building. And so when we finish talking about this framework, I'll talk about a system that we use at Duo Security around data synonymization to understand a little bit more how you would apply this framework in these lenses. Here's the data science lifecycle framework that's used here in Ethos. There's often, everyone I think has their own data science lifecycle framework here. And I generally think this one's pretty robust, though obviously there's often several nuances. But I think the takeaway here is the call out of some of the stages that we don't typically think about from the people and process perspective. And I think when I think back to some data science education or what a lot of projects focus on, it's often the discovery. Let me get the right data I need. Let me do the analysis and then the modeling. What we don't often spend enough time, and I'd argue differentiates really strong data scientists, is the problem identification, that question aspect. Then we have towards the end of the process, that interpretation and drawing conclusions, and then the communicating findings to diverse audiences. And I think these are often underrepresented in the time that we spend in these workflows, but are equally as impactful. And as we think about applying these lenses to the different stages of the lifecycle framework, for example, in the problem identification, that question section, positionality might ask, how might your identity and experiences and personal situation impact your understanding of the project or the project stakeholders? If you had, for example, we're working on a cybersecurity project and you were impacted by a data breach, would you maybe take a more risk-averse approach to developing the system because you had a personal experience in that? When we think about the data discovery phase, a systems-based lens might ask, where does the data for the project come from? What methods and what systems do we rely on to access the data? And do we really understand how it's being generated and who's responsible for generating the original data? And I think these are the important questions to ask, because even before we get into the analysis stage or picking the specific model, the choices we make around data aggregation and schema creation already start to add our personal influence and our own bias into this framework. And one final example of the power lens here on the interpretation and conclusion step, we can start to ask, what do false positive and false negative mean in the context of this research? And how would false positive and false negatives impact the implementation of this work in predictive technology, for example? So these lenses allow us to examine each of the different stages of this life cycle framework to ensure that we are thinking through these critical factors that often have an outsized impact. So when we're applying ethos in cybersecurity data science, this ethos framework allows us to guide the creation of algorithms and analyses that hopefully ensure more equitable fraud protection and mitigate biases. It allows us to keep in mind some of the concerns around logging and monitoring systems so that we can ensure that data that we use to keep people safer doesn't all violate their privacy in the process. And overall, I see us applying this ethos framework of finding that balance between security needs with fairness and privacy. We could probably design a very, very secure system if we just collected everything. But that swings us on the scale of, violating user privacy and fairness. And so I often say the most secure data is the data you don't collect. So again, we straddle that line of how much to collect and how secure do we want to make the system, because there are trade-offs. When we think about recording new fields at Duo, we think through what is the pseudonymization process they might go through. What if a malicious actor got their hands on this information? And asking ourselves those questions is really useful to start to gauge and take that adversarial thinking approach that I believe helps us, maintain fairness and privacy importance. Throughout the presentation, we've talked quite a bit about different trade-offs we have to make here. And so I just wanted to specifically call them out. First, we have that security versus explainability. And this is really thinking about how do we balance interpretability with performance. And this goes back to that less accurate explainable versus black box and no idea at all where the results are coming from. And it is certainly a curve here of interpretability, in this case, versus accuracy. But I thought it was, a good depiction for us to understand the choices and trade-offs we have to make and how we are making these decisions of the technology that we're going to use. And already that's adding in our own bias and our own values into the system that we're creating. And that same thing goes over for privacy versus utility. And so this is the challenge of how much you anonymize and then the risk of re-identification. There was an anonymized Netflix data set that came out in 2008, where researchers were able to re-identify that anonymized data, for example. And so you need to find this balance of pseudonymization with maintaining privacy and that analytical utility as well. And ideally, right, we try to shift that curve along. But we certainly know, right, if you don't collect anything, the privacy is great, but a utility of the system really decreases. It's all about striking balances here, which is why we're making these very subjective decisions in system design. And it's why I think we need to consider frameworks like these and think about where the environment that our systems live in. A question to the audience: can you think of an example where privacy concerns limited how data could be used? In the previous slide, we talked about one example, right? Which was Netflix providing this anonymized data set, I believe for research purposes and other things, and then ultimately it being re-identified. And so then when, because of the implication of that, we certainly see that, they're not sharing a ton of Netflix data anymore because of that situation. And so that started to change how data might be used for certain purposes. I see overwhelming sensitive patient data. We certainly see some financial and census data with USDA payment, healthcare, student financial, confidential patient data, medical records. Yeah, certainly working and thinking through HIPAA regulations like GDPR, and especially with medical data, we see there's a heightened scrutiny of how we use that data. And I think certainly there become roadblocks in the utility. We even see it at Duo with if we didn't take all of these data privacy approaches, we would have this great utility of all access to all the data, but we know that we have to strike that balance. Yeah, military as well, high-tech data. Yeah, exactly. You folks are totally getting it. It's striking that balance of utility versus privacy here. So let me talk a little bit more now that we've gone through some examples and talked about those trade-offs of how we try to strike that balance at Duo. And so here's a bit of a case study here of how we do data pseudonymization at Duo. And so this system was designed a few years ago to think through how we could anonymize sensitive data while preserving its analytical utility and ensuring that security data remains accessible without compromising privacy and security. Not only that being a mouthful, but that's a certainly audacious goal for a system. And then we run into all these compliance questions of how do we maintain GDPR and our contractual commitments with our customers, as well as good data governance practices, while preserving privacy in the system that we make. And so obviously, we needed a way to access the data of Duo customers that maintained compliance and security, that removed sensitive information, and ensured that we could use it for research purposes to help improve the product and ultimately benefit our customers. And so the solution for us at Duo was to build a system that performs a system that builds an opt-in schema model that performs in-region extraction of data that helps us bring the data into a central data lake without disrupting the functionality of our systems or going against any of our contractual compliance commitments that we've made. That was just like a big mouthful of words. So what does that mean? So one of the key things here was not only are we accessing data from our production databases, but we have to consider that when Duo goes down, it has a wide-reaching impact. So we need to make sure that the systems that we design are, not only have all of the privacy and security concerns, but they have the reliability to not impact our production systems. Next, to really think through that compliance of the data that we're bringing in, we have this opt-in schema model. So no data will ever automatically go into our data lake for this project unless we've specifically said we want to bring in this field and here's how we're going to handle it. And so that really comes in that auditable and updatable aspects of this by saying this field is a customer name or a customer email. We are going to drop it, or we're going to hash it. And we're going to hash this ID. And the creation of this system was really useful because it allowed us to maintain compliance while also having a very accurate understanding of the schema of the different data models and drilling down to understand what is this field doing, how do we think through the sort of threat model of recording this field, and then how are we going to treat it in our system. And ultimately, this allowed us to provide more access to the data at Duo because we had it synonymized and allowed us to open it up to researchers and other folks across the organization. But there's lots of challenges in data synonymization, right? When does data transformation go too far? Right? How much do we sort of lose that utility? Are we really protecting privacy, or are we just making data harder to use? What about data misuse and potential re-identification? And how do we make decisions between synonymization or techniques like differential privacy? Differential privacy is generally a framework that allows folks to do analysis on data, but it sort of ensures that the analysis they're doing doesn't compromise the privacy of the individuals because it's achieved by introducing controlled noise to that data set. So you can't pull out any one single user, but you can still draw general trends and insights. So would that be a better approach versus pseudonymization? I don't have answers to all of these questions, but it's a part of the framework to start to think about these important questions and continually reevaluate them for the systems that we build and we use every day. When we think about the ethos framework that we discussed just a little earlier, here's how I might think about applying it to the data synonymization system that we have at Duo. When I think through, and this is not going into the specific life cycle, 6 different life cycle events, but just some of looking at it through our different lenses here. When we think about the lens of power, we think about it allows us to redistribute control over some of the Duo telemetry data. And it allows us to enhance user privacy, allow the data to be available for research, and then it starts to influence data governance practices. When we think about the narratives, I would say that this really aligns with the privacy protection narratives and the ethical data approaches that we take at Duo. So it's no surprise that a system like this was developed by our team because of the strong values and narratives we have at the company. The positionality starts to think about the background and biases of those developing the tool. And so I certainly see we take a very conservative approach to deciding what data allows us to go in, we allow to go into this system. Because we bring in the cybersecurity background, past experiences of data breaches, we want to be really intentional about the data that we bring, and we bring that bias into the creation of the system. And then finally, thinking through the system living in the whole socio-technical system at Duo, this is really thinking about the social factors here, which is the user privacy expectations and regulatory compliance, which we communicate to our customers, as well as those technical components. So the algorithms that we use for hashing and the systems that we use and where we process the data as well. And overall, considering both of these factors allow us to have this balanced data protection approach. We've talked about the framework. I've said data synonymization a ton of times. Now I have a question to you folks. Legal has come to you with concerns about your data synonymization approach. What do you do? Do you go ahead and proceed? Do you delay the launch and do some more research? Do you scrap it completely? Or do you ask for a more formal ruling from legal saying, yes, you're concerned, but are you going to let me do it or not? I see some answers coming in here. Let's see. Delay launch, ask for formal ruling, scrap approach. I'm showing the results now, so we might have some more groupthink here. I don't think there's, well, maybe apart from proceed, there's probably no right answer here, though I may have accidentally clicked delay launch. But I think depending on the situation, in this very broad question, delaying the launch, chatting with legal more, totally going for a different approach, all could be valid approaches we take. And what I wanted to highlight here is the subjectivity often of concerns that are brought up and our own reactions to them when we're designing these different systems. Awesome. And Jen, can I just get a quick time check here?
Yeah, I think we've got about 10 more minutes for questions if you want to wrap up soon.
Perfect. I have got 2 more slides and then we'll be good to go.
All right, great.
Thank you very much. So just to close, folks, I really encourage folks to think about embedding a socio-technical mindset into your daily work. And so this is, thinking beyond the algorithm and how do you integrate people and process considerations. because we know that these socio-technical considerations affect the development and deployment of our security systems and not just the technical decisions. And we certainly see here that we benefit the most when we have interdisciplinary collaboration between data science and other roles like security engineers or like the legal team in that last question. Wrapping us all up here, I started talking about how cybersecurity is a socio-technical challenge, and I want to broaden this to say data science and building technology and systems is also a socio-technical challenge too. Human and process elements often have a more significant impact sometimes on cybersecurity outcomes than algorithms alone. The takeaways that I want folks to consider today are thinking beyond coding. So using a socio-technical understanding is critical. Thinking how you can learn to navigate different security risks, not only if you're in the security domain, but thinking through adversarial actors and how people might misuse the systems and tools you're building. And then finally, how ethics can be a daily practice, something that we revisit, not just a one-time consideration when building these systems. And that's why frameworks like the ethos framework we talked about can be really useful in doing that, and just a helpful guideline to ask probing questions when you're in those different stages of the data science model development. So I want to thank everyone for your time today. I think we're going to open up the floor to questions. So thank you all very much.
Thank you. That was so interesting, and I think really sort of humanizes the decisions that are being made around data, around security. And I'd like to kick us off with a question on thinking about automation. I feel like multi-agent systems are sort of all the rage, and we're talking a lot about autonomous decision making. How does the framework change? What do you think is the frontier right now in thinking about how do you adapt these frameworks to work in multi-agent systems? Sorry, that's a really hard question.
Yeah, I mean, I have a few thoughts. I think ultimately it falls on the system designers to start to think through how do we embed important frameworks that think through the social, ethical, privacy, and security concerns of these multi-agent systems. I think it's important not to necessarily abdicate responsibility because an AI is doing it, because someone did build that system, provide a directive. And so I think we can think about it from the individual responsibility as a researcher, but then as we dive deeper into multi-agent systems, I wonder, and mind you, I'm not necessarily in that field, but I wonder what it would look like to think through embedding different decision frameworks like the ethos into the system itself as it is making those choices, and as it is an actor performing, doing different things. How could we think about training different models to think through those considerations? I don't have a great answer. That's sort of the question of the day right now.
Yeah, I think everyone is sort of grappling with it right now in real time. More generally about pseudonyms, I can't say it. I'm challenged with my words today.
Data pseudonymization.
Pseudonymization.
Yes, don't worry. I had to say it a million times in this presentation, so I've got you.
Thinking about interoperability across borders, across cultural contexts, tell us a little bit about how you think about the flexibility of these systems and how you're able to think about how portable they are.
When I think about the interoperability, there's likely a few factors that come to play here that I think are influenced not only by, national compliance standards, depending on where we're operating, but also cultural standards as well. I think of an example when I was on exchange in Denmark, where it's very common for you to put your marital status, a picture of yourself, and a lot of background information on your resume for when you apply for jobs. And that was a cultural norm. And that takeaway for me was, depending on the country that you're in, there are different cultural norms around what we view as PII data often, while we do see regulations starting to standardize that. And so the decisions that are being made there, I think, are impacted by those unique cultural norms of how people view the privacy and security of their data. And then with the interoperability, I think that comes into play when we think through legislation like GDPR and others that think through drawing regional boundaries of data processing. And so, for example, the system that I talked about today, we do in-region processing and anonymization of the data before we ever move it out of that region, because it can only leave that region when it's in a certain state. And so I think approaches like that I think you take the ceiling of the most rigorous compliance that you're sort of dealing with in a group of countries or regions, and that probably has to be your floor for your system.
Yeah. Do you find that, do you often run into it affecting the utility then of the data? Or is that, or do things feel flexible enough that you're still able to get what you want out of it?
From where we were a couple years ago when all the data lived in production systems and you had to make specific requests and things like that to access it, so much more utility. When I think about today, though, yeah, when I'm doing an analysis, sometimes it'd be great to have some of that PII data or more information about the customer or how they are naming, different things that they use with Duo. But we take a stance that we're not going to bring that into our system. And so it does impact the utility. And that's a real consideration here of like finding that line of trade-offs. And you hope to design a system that has enough utility to bring value, but not so much that you no longer consider the privacy of users. So yeah, I would definitely say that day to day we sometimes get frustrated that we don't necessarily have this data, but we know it's in service of the compliance and privacy preserving values that we have for our customers.
Yeah, we had our wonderful student co-op write a blog post on our recent winter workshop, and so much of it was centered on on human decision making still in designing these systems. And I think that this is just another really great example. We do have another question here, and this is about sort of its process, right? So Andy writes, most security experts say that baking security into the development as early as possible is much easier to do than as an afterthought when rolling it out to production. But with AI/ML systems and models, they start as almost research and development and may require many iterations, as some worry about security controls slowing it down, destroying, just slowing down the whole process. So
Yeah.
what are your recommendations for companies to balance when to bring security into the development process? Generally, what are your thoughts on how do you bake in those key milestones to be used to mark security control introduction?
I would generally still take the approach of security as early as possible.
Yeah.
But what level of security, especially during the research and development phase, sort of maybe leans towards using a framework like Ethos and asking those important questions of how much are we maybe willing to slow research and development to ensure that we are thinking about security early on. Because certainly if we don't think about security, we could probably fly ahead. But then all of a sudden we've designed a system that may not actually in practice work with the process and the people that we want it to. And so I probably bring my own biases here of responsible AI and technology and working for a cybersecurity company and say as early as possible to start thinking about it. But I think it necessitates having those conversations of how far do we want to go with the security early on. And I think that is that's that human factor of deciding how much do we value that. And I think we should value it a whole lot, especially when we think through the privacy and ethics of building AI and ML systems. But we also have to acknowledge it does slow development. So how do we think about embedding those milestones of saying the moment before it goes into any sort of alpha or beta testing with real people, we need to have these controls and compliance in place. But obviously, it's harder to add if you don't start them from the beginning. So it is sort of a double-edged sword, I think, when making a lot of these decisions.
Yeah. I again, going right back to the human element, and I think that there is such a great argument, right, for the social sciences embedded directly into technology. Okay, I have one final question. This comes from Liz Langdon Gray, our executive director, and I know you'll see her at the ADSA conference next week. Have you seen the TV series Prime Target? Is the premise even vaguely within the realm of possibility?
Oh no, I haven't seen the TV series.
Oh no. Okay, I haven't either. So someone's gonna have to
Oh,
explain this one to
you know
me.
what? Liz, we'll talk about it next week. And yeah, I'll do some research and get back to you on that one.
All right. Well, to close us out, we do. I was called out last season by our friend Andrew Schroeder at Direct Relief that I'm doing the Ezra Klein thing. But if you've got one book recommendation, what would be? I know that you dropped a book very early on in your presentation. Please tell us what that is again for the audience, and then also let us know if there's anything else you recommend for reading.
Ooh, the book I talked about is a textbook, so it's not light reading, but it's called Data Science in Context: Foundations, Challenges, and Opportunities. And it's by Alfred Spector, Peter Norvig, and Chris Wiggins, and Jeanette Wing. And so they wrote this textbook that I think starts to get at a lot of the things we're discussing today. And I think it's nice to see textbooks um, that aren't just technical in nature, that are acknowledging some of these things. That one's probably a pretty dense read, though I certainly recommend it. The other book that's a favorite of mine is Automating Inequality by Virginia Eubanks. And this is a book that I think really touches on thinking through socio-technical systems. It examines several public sector initiatives and algorithms and how bias is introduced into them uh, and how, and it goes to the whole title of Automating Inequality, of how the unique biases of what has been done before just become perpetuated in the technology that's created by those same people. So that's a great one as well. That's not a textbook and probably a bit of a lighter read that I think dives deeper into socio-technical systems and challenges.
Well, thank you. And thank you for the suggestions. We know those names well, and so that's terrific. All right. Well, I am going to close this out. I'd like to mention that our next industry seminar will be on April 17th at 1:30 p.m. with Amy Smith from Intuit. Registration is available on our website. That's datascience.harvard.edu, and also through our weekly newsletter. So if you haven't signed up, sign up. We hope we'll see you there. With that, thanks once again, everyone. Thank you so much, Scott. This was such a delightful session. And yeah, we really appreciate your time. All right.
Thank you,
Thanks.
everyone.
Take care, everyone. Have a great afternoon.